All right. Well, happy Monday. Happy fourth week Monday, and we'll get started. And today we'll look at data wrangling with dplyr. We introduced the tidyverse on Friday. Oh, I've also posted up homework 3. That's available on Canvas, and so you can look at that and get started. And we'll look at data wrangling. Before I do that, I got to do this grumpy professor chat thing. I don't think this applies to most of you who are here right now. Maybe but maybe if you're watching on the video or anything like that, a couple, we graded homework 1 and we posted the grades. So if you haven't seen it, you can take a look. And there were a couple students who made a silly mistake, but it kind of dramatically affected their score, because either the file for their script didn't get read in, or the file for their month names didn't get read in. And so, it just produced a whole bunch of errors. And, we got some regrade requests, but pretty much if this happened, we're not going to give you your points. Okay. So I think I emphasized this, on the first day it's in the syllabus, or maybe I don't know, but it's your responsibility to read through your knit file after you do your markdown and you click knit and it produces your PDF and stuff. Make sure you read through it. Make sure the output shows up before you submit it. Okay. Because if your output looks like this, if you get these warnings, right, and it says, can't open this file, no such file, and then you get these errors, can't open the connection, stuff like that, we're not going to give you your points back. Okay, you're not going to get any points in a regrade. All right, and I know it's not fun. Okay, it sucks. You worked hard, and then you make some kind of silly mistake like this, and then and you lose a bunch of points on it. And that's it's disheartening and it's discouraging when that happens. And as far as the homework goes, maybe you lose some points on your homework, and it might affect your final grade by a few percentage points. Okay. In my opinion, and again, this is my opinion, again, because I'm also kind of removed from this whole thing, I think if you lose a few percentage points, it's still that consequence. If it helps you remember things like this and to double check your work in the future, I feel like that's a good, it's a reasonable cost to learn this lesson the quote unquote hard way. Okay. Of course, it's better if you didn't ever make this mistake and you never had to learn this lesson the hard way. But, in the future, you might be applying for a job, most likely. And a lot of jobs will say something like, we're looking for somebody who's detail oriented, right? And sometimes this feels like it's just such a filler thing that just every job kind of puts on their thing, right? We need somebody who's a team player, and we need somebody who's a self-starter, and we need somebody who's detail oriented. And these are just kind of like things that people throw in some job description. But a lot of times what detail oriented means is that a small silly mistake can end up having large consequences. And this company or whoever's doing the hiring wants somebody who's going to double check, triple check their own work before they submit it or pass it on, right? So, for the homework, you make a mistake, you lose some points on your homework. Just imagine a slightly different scenario where you make a small mistake, such as you didn't check the file name, or you didn't double check the contents of the file before you sent it off, right? And I get it. I make these mistakes too. And hopefully just not in these really important scenarios. But imagine applying to graduate school, right? And you write up a personal statement, and you've kind of modified each personal statement, and you say, I'm excited to apply to, Stanford University, or I'm excited to apply to Duke University. And what if you accidentally sent the personal statement that you wrote that says Duke, and you sent it to Stanford? Okay, that's an embarrassing mistake. It's a small mistake. It's just a matter of like, I didn't check the file name, or I didn't, I accidentally dragged and dropped the wrong file. But what's going to happen to your application? They're going to read through that, and then they're going to just toss it out, okay? Because you got the name wrong, right? Or what if you accidentally CC the wrong person on an email and there's like confidential information in there, right? That could lead you lead to, you know, some bigger trouble. You know, that there's, you know, all kinds of, I don't know, scandals, not scandals, but not really not that big of a deal. But, you know, it's just like, you know, in the Zoom chat, there's a difference between privately chatting, somebody sending somebody a message and then accidentally sending it to everybody. And that can be embarrassing, right? And it's a small mistake. It's just a little drop down in that thing and you respond to everybody, or you respond to the wrong person, something, right? If you enter just a single wrong digit on, say, a bank account number, oh my gosh, that's trouble, right? A lot of things, they try to avoid this, right? Like on Venmo, there's kind of like a second stage where you have to confirm that you have the username typed in, and you know, you see the picture and stuff. But sometimes there's not a second stage to double check to force you to, and you could end up making a mistake sending, right? Or an extra zero in the dosage of a medication that could actually end up being fatal. And you know, I want you to achieve all of your dreams, all of your potential. I don't want some silly mistake like this to, you know, mess things up, right? And so if you don't take the time to double check, to just make sure you didn't make a silly mistake like this, you know, that could mess things up. So please double check your work before submitting. Okay, thanks for hearing out my rant there. Let's go ahead and take a look at our content for today. So we are looking at dplyr. Dplyr is part of the tidyverse. We've introduced the tidyverse with tidyr and pivoting our data and reshaping it. And you can load up dplyr individually by calling library dplyr, or you can just load up the entire tidyverse by calling library tidyverse. And tidyverse advertises itself as saying it makes your data science work easy, because it's going to give you some structure to this, right? If you think about what needs to happen when you work with data and you want to create and extract the information that you want, at a very, very high level, what do you need to do? You got to figure out what you're going to do. You got to figure out how you're going to write that into a computer program, and then you write the program. Okay, and those are the steps, right? Think about what you're going to do, write it, do it. And what tidyr does is it provides you a set of verbs. It kind of constrains the options as far as the verbs that you can use. And it forces you to kind of think of what it is that you're trying to achieve in kind of these operations. And with these operations, you can actually achieve almost all of the data wrangling jobs that you need to do. So let's take a look at what these options or what these verbs are. Okay, it says dplyr is a grammar of data manipulation, providing a consistent set of verbs that help you solve the most common data manipulation challenges. And our verbs are select, which is going to select columns. You use them to pick variables. Filter, which is going to select filter rows. You pick their cases based on their values. Mutate will create new columns of variables. Arrange will reorder the rows, and summarize will take the values and boil them down to a single summary. I'll take multiple values and boil them down to a single summary. There's also another function called group by, and all of these functions combine very nicely with group by, and that's, I would say, really the power of dplyr. And we'll take a look at some examples here. Before I get too far ahead of myself, I highly recommend that you download this cheat sheet. All right, there's a bunch of functions, and you can just get this. This is produced by RStudio. dplyr is kind of part of RStudio's. You know, RStudio is really designed around the tidyverse, and it works very well. And you know, my notes I think are handy. I think my notes are pretty good. But then again, each of these slide decks are like 50 slides long. So the cheat sheet makes the gives you a kind of handy, you know, one-page resource, which I think is great. Okay, let's take a look. And for these examples here, I'm going to use this data set called the Star Wars data set. And I don't know if you are fans of the Star Wars franchise of movies. It doesn't really matter, but there's 9 in the Skywalker saga, and this data set was created, I don't know, maybe 9 years ago, 10 years ago. How one was The Force Awakens released. It was this data set was created between The Force Awakens and The Last Jedi, and so it has information about the various Star Wars characters from the first 7 Star Wars movies. So that includes the original trilogy, the prequel trilogy, and The Force Awakens. And we've got 14 variables, 87 different characters, named characters, and we have information. So we have Luke Skywalker, a height of 172 centimeters, a mass of 77 kilos, blonde hair, fair-colored skin, blue-colored eyes, born in the year 19. I think this is in the Star Wars universe. They measure based on years before the Battle of Yavin. Battle of Yavin was when the Death Star blew up. Sorry, spoiler. And apparently Luke was 19 during that battle, and so his birth year was 19 years before the Battle of Yavin. Male, sex, gender, masculine, homeworld from Tatooine, species human. There's 3 more variables. A list of films that Luke Skywalker appears in, a list of vehicles that Luke Skywalker has driven, and starships that he has commanded. And then we can go through and look at the next character, C-3PO, and there's all of this information. With the data set, you can select columns using the variable select. So we're going to say select from the Tibble Star Wars or data frame Star Wars. Select these columns. Select the column name, homeworld, species, and films. And this is what we get. Okay, name, homeworld, species, films. It selects those columns, and we have that. Okay. We've seen the pipe before when we introduced rvest, and we saw, you take the output of the previous function, and it gets piped in to the next function. And so when you see something like this percent greater than percent, that's the pipe. And so when you see x piped into f of y, this is exactly equivalent to applying the function where the first argument is x. Okay, x gets piped in as the first argument in the function f, along with following arguments y. So the output of 1 gets piped into the next step. So more frequently than seeing it written as select Star Wars name, homeworld, species, films, more likely you will see this. I'll take the Tibble Star Wars and pipe it into the function select, and the additional arguments in select will be name, homeworld, species, films. Okay. When you use all of these verbs in dplyr, a lot of times your commands end up getting a little bit longer. There's probably ways to achieve the same thing using different commands with less code, and that's fine. But I'm actually a fan of dplyr, and I'm a fan of kind of writing kind of verbose things that are easier to follow than very short and concise things that are a little bit trickier to solve, right? And on Campus Wire, I see this game where it's like, how many lines of code did you write to solve this function? And that's totally fine, and that's a fun game to play. But me, I write lots of things. I write lots of comments, and I don't know if the comments are included as part of the lines of code. But I write lots of comments, and I generally write my lines short, where I just achieve kind of like one task per line, and I feel good about the way I code. And it's always written kind of with the goal of, if I have to read this later, is it going to be easy for me to read? And I try to write with that goal in mind. So sometimes my code is quite long, but I think it's pretty easy. Shortcut to insert the pipe, Command or Control Shift M, and this will insert the pipe, and you don't have to type in percent greater than percent. You can just type in Control or Command Shift M. So let's keep looking at this verb select. We can say Star Wars and select all the columns except, and you put a minus sign, And this will select everything except these columns. So if I say select everything except name, eye color, and birth year, we get these 11 columns. We don't have the name, eye color, or birth year, but we have all of this other information. And I piped the result of that into head 3. So we're just selecting the top 3 rows from the resulting table. Here is select, but we are using colon notation. And so we can say select all of the columns from name through eye color. So we've got name, height, mass, skin color, eye color. Compare that to the original table, and it's basically just selecting the columns starting at name, going through eye color, and it's going to skip out all of these other columns here. So you can use colon notation. We saw this when we were dealing with tidyr. So in tidyr, we saw the colon notation as far as which columns we wanted to gather, and we can do that here with select as well. You have some helper functions that can be used along with select, okay? And so these helper functions, and you can read more on tidy select helpers. These will help you select some of the columns based on certain criteria. So you can say contains, and it will select all the columns that contain a certain character string. Starts with or ends with, we'll select columns that start or end with a certain string. Matches, and this matches or whether the column matches a regular expression or not, which is very powerful. And we have not covered regular expressions, but I will cover regular expressions on Wednesday's lecture. So that's a very exciting lecture. I feel like today's lecture is one of the most important lectures of the quarter. I know, like the very first day I said this is probably the most important lecture, and that was like just a life advice or something. And I don't know, I still stand by that statement. I think knowing that you have choice over, how you're going to spend your time, that's an important thing to learn. And many of you might have already known that, so that's great. But the lecture on dplyr, I think, is probably one of the most useful lectures that we have. Everything will select all of the columns. Numeric range is great if you need to select columns where you've got this, like a government data set often has like terribly named variables, and you might have like x1, x2, x3, x4, and you need to select columns there or something like that. You can also give a vector of names, and you can use something like one of or all of that will select columns from there. Okay, so here's just a couple examples. We've got Star Wars select columns that end with the string color. So we're going to get select the name along with columns that end with color. So we get name, hair color, skin color, eye color. Here's a regular expression. This regular expression is equivalent to basically the string ends with the letter S. This is $, means S needs to come at the end of the string or at the end of the name. And so we're going to select name, and then we get mass, species, films, vehicles, starships. These are all the columns that end with the character S. Here is a vector called vars, and we're going to say select the columns where the names are in this vector vars. Name, mass, height, we throw that into Star Wars select all of vars, and we get the columns name, mass, height. Okay. And a question was, can I just do Star Wars select vars? And the reason why you don't want to do Star Wars select vars and you want to throw it into this function all of vars is, well, for now it's fine, but what if your table had a column called vars, right? Now it becomes ambiguous. Do you want to select the column called vars, or do you want to select all of the columns in the vector called vars, right? Or what if this vector was not named vars, but was named, say, name, okay? Select name. Do we select just the column name, or do we select the things here? Okay, what if one element of vars doesn't exist? I think we're going to get different results whether we call all of or any of. All right, so let's take a look here. Okay, so here I've got let me clear my environment. All right, so we're going to do data Star Wars. All right, so here, this is what we have. Vars is here. We're going to do so we got vars there, Star Wars, all of vars, name, mass, height, and then any of, any of vars. Okay, that they return the same. Okay, let's do vars 2. And let's put in something like house. Okay, so that's not a variable name. Okay. Let's see what difference we get here. Okay, all of this gives me an error. House doesn't exist. Any of doesn't give me an error, okay? Because it just says, so it's going to give me anything that matches. House doesn't exist, so there's no problem there, okay? So when you say all of them, I need all of them. This is a problem because house is not a variable that exists. Any of them, we get the ones that do match. There's one of, let's see what one of does. I think one of and any of, warning message, unknown column house. Okay, one of is kind of like any of, except it gives me back a warning message. Let's do one of. Nope. Tidy. We want one or more character vectors. One of is superseded by any of and all of. Okay, so we have any of. Okay, so you got one of, any of, and all of. And I guess any of and all of are the preceded, the better ones there. Okay. Let me give you your first view quiz answer. Today's first view quiz answer is B. B as in bear. B as in bear. Filter rows with filter. So you want to select certain rows. You want to filter down to certain rows. We use filter. And you just give it some kind of logical vector. So here we're going to say is name equal to R2D2. And it's going to just give me the rows where this is true. And that will be the row where the name is R2D2. Simple enough. Here is something just a tiny bit more complicated. Give me the rows where the species is in human and droid or droid. In this vector human, comma droid. And height is less than 175. So we're going to get all of the rows. There's 16 characters in the data set that meet this criteria. Humans or droids, and height is less than 175. This is what we have. Luke Skywalker, C3PO, R2D2, so on and so forth. Okay. So using comma is the equivalent of using an and sign. You can use filter along with a regular expression. And so you can use string detect. String detect returns a logical vector. And we're going to say, hey, detect in this string of names, does it, and this regular expression means the name starts with the character capital F. Capital F. And so there are two characters in Star Wars that start with a capital F. We have Finn from the new trilogy, the sequel trilogy, I guess. And so these are in Force Awakens. And then I don't know who this is. Somebody else from Coruscant. I don't know. Capital F. You can use the or using the vertical bar. So we can say filter. We want all the characters where the hair color is none or eye color is black. And from there, don't give me all the columns, just select these columns: name, species, homeworld, hair color, and eye color. So we get Darth Vader, whose hair color is none, with yellow eyes. We get Greedo, who has missing hair color, but black eyes, so that's fine. Nien Nund has both none, no hair, and black eyes, and so on and so forth. Okay. Once you have the columns you want and you filtered it down to the rows you want or whatever, even if you haven't, you can also rearrange. You can arrange your resulting table using the function arrange. So this will just kind of put the variable based on that, arrange the rows based on that variable. And if you want them in descending order, you can wrap descend around whichever variable you want. So here we're going to arrange them based on birth year, and then we'll break any ties using the variable mass. So we're going to put them in arrange descending order. So Yoda, oldest character, 896 years before the Battle of Yavin. And I think this is based on a throwaway line from Return of the Jedi, where, you know, he's talking to Luke and says, when you're 900 years old, will you look as good as me or something? And apparently Return of the Jedi happens 4 years after the Battle of Yavin. And so they say, oh, it's got to be born 896 years before that or something. Okay, who knows? Okay, so we got 896, 600, et cetera, et cetera. Okay, 92, these two people have 92, so we're going to break the tie based on mass in ascending order. And this is what we have, and I don't know who these characters are. Finis Valorum, that was the character that started with an F. This is what we have. Okay, sort rows in arranging order. We can select rows based on their position with slice. So slice will just, you say, I want the 5th through the 10th row, right? And we get from the original table, in the original data as they appear in the order of the original table, we can select and slice just down to the 5th through the 10th row. So that's fine. You can select just certain portions of the table. You can find the 20th row or the 30th row. Now notice when you do that, it renumbers the table, the resulting table from 1. Okay, so in the original table, Leia is in row 5, but now that I've sliced it down, it renumbers these and goes 1 through 6. Okay, so in the original table, this was 5, 6, 7, 8, 9, 10, and now it's 1 through 6. You can also do slice sample. Slice sample will just randomly select rows from the table, and this is good for getting a glimpse of your table. A lot of times after you do an operation, you want to check if the operation worked. And if you want to check if it worked, a lot of times we kind of like say, all right, give me the head of the data frame, head 5, head 10. And you look at the first 5 rows, first 10 rows, and that's great. Oh, we have a question. Can we slice columns? So with slice columns, you use colon notation. You basically say select, and you go, from this column through this column. So you can use colon notation with select. Okay, so anyway, the reason why you might want to use slice sample versus say head to check if your operation worked is because head only gives you the top of the table, and stuff at the top might be different from stuff at the bottom or stuff in the middle. And so by doing slice sample, it's going to just randomly select rows throughout the table. And when you select rows throughout the table, you might get a glimpse of some of the values elsewhere, and you can just check to see if your operation worked. I highly recommend anytime you do an operation, to do an operation and then do slice sample or something to kind of just check to make sure that operation did what you want to do, right? I compare this to, like, say, cooking a soup, right? If you're going to cook a soup, after you add some salt, you're going to stir it up and then taste it. Okay, you don't want to add like 1,000 ingredients, do 50 different steps, and then taste it at the end and go, oh, this is not what I wanted, right? You want to do kind of one step, stir it up, check, and then if it's good, you can make adjustments. Or if it's good, you can leave it as is. If it's no good, you can make adjustments. And it's good to frequently and regularly check to make sure your operations are indeed doing what you want it to do. Slice min and slice max allows you to select rows with the highest or lowest values in a certain variable. It's kind of like arranging it and then selecting the top rows. Okay, so here we're going to do slice max on mass, and so this this will do is we'll select the 3 characters with the heaviest mass in our table. We've got Java, and this is Grievous, IG88, and these are the ones with, you know, Java the Hutt has the highest mass, and that's what we have. We want to create new variables with the variable mutate. Oh, let me give you your second view quiz answer. Second view quiz answer is E. E as in elephant. E as in elephant is the second view quiz answer, the letter E. We can create new variables based on the existing variables. When you create a new variable, it will get added as the last column. So if you want to see it, especially if you have a bunch of columns, you're going to want to use select and select the new variable that you created. So here I just say, hey, let's create a column called height in inches, height in, and this is going to be our height currently measured in centimeters. We're going to divide by 2.54, and this will give someone's height measured in inches. So we do mutate height in is equal to height divided by 2.54. What's the first row? And we get this, and we can see the new column height inches appears all the way at the end, and that's not what we want. So I will do the same thing, mutate height inches, and then we're going to select name height and height inches, select the first row, and we get Luke Skywalker, height 172 centimeters, which is equal to 67.7 inches. And there's our answer. When you use mutate, it's going to create a new column. And so this new column needs to have the same number of rows as there are, or the same number of entries as there are rows in the table. So if your table has 87 rows, your new column needs to have 87 values. So if you used a function like mean, it's not exactly going to work. Okay, I might just duplicate the value. Let me just see what happens. All right, so if I do select, if I do Star Wars mutate, and we're going to do mean height is equal to mean of height. Select, say, mean height. It ends up putting the same value of 174 point something in for every single person. Okay, it recycles this value for every single person, and this is probably not what you want. Okay, again, what you want, you have to think of this as a new column, and so every person should have kind of a unique value. And so instead of mean, you maybe cumulative mean. Now, I don't know, cumulative mean doesn't really make sense in the context of characters here, but perhaps if you've got a time series data set or something like that, the cumulative mean might make more sense. And this is basically what is the mean of the values we've seen so far. So we start off with 77. What's the mean so far? 77. Now I have 75, 77, 75. What's the mean so far? 76. 77, 75, 132. What's the mean of these 3 values so far? 61.3. And so the cumulative mean will give you the mean values of kind of the cumulative values that we've seen so far. These are other functions that are useful as far as mutate goes. You know, if you have columns and you're just going to like do arithmetic operations between them, then that's fine. But again, just keep in mind you need a vector of values that's going to end up going into your column. So you have P min, P max, that's LNY's min and max, cumulative min, cumulative mean, our cumulative minimum and max, cumulative sum and product. Between will be a logical vector, are the values between A and B. You've got lead and lag, which will basically copy the values from another column with an offset, and then Entile will bin them into different N buckets. So here's just a few examples of some of these new columns that I'm going to create. So we're going to select the name, mass, and birth year of these characters. And then I'm going to create a column called the cumulative min mass. And it's going to ask, what is the minimum value that we've seen so far? So first value I've seen is 77. That's the smallest value I've seen so far. Next value I see is 75. That's the smallest value I've seen so far. The next value is 32. That's the smallest value I've seen so far. And the next value is 136. The smallest value I've seen so far is 32, and so on. The smallest value continues to be 32 until we encounter another character who might be have a mass less than 32. The ratio, we're going to take the mass and divide by the mean of the mass of everybody. So we're going to calculate the mean of everybody, which if I did this, except not the mean height, if I did the mean mass. Okay, the mean mass of everybody is 97.3. What we will do is we will take 77 and divide it by 97.3, and we get a ratio of 0.791. And we do this for every single character. So we can calculate the mean for everybody and then use that to calculate these values. Okay, P-min, this is element-wise minimum maximum. And we're basically giving it two columns, the mass and birth year. And we're saying between these two columns, which value is smaller, the element-wise minimum. So between 77 and 19, what's smaller? 19. Between 75 and 112, what's smaller? 75. Between 32 and 33, which one is smaller? 32. That's the element-wise minimum. So you're basically giving it, a vector of mass, a vector of birth year, element-wise, which value is smaller. Lag, we're going to lag mass year P min. We're going to take this column and create a lag, which basically copies the values, and we're going to offset it by 2. So I'm going to take this number 19 and 75, 32, and we're going to just copy them, but offset them by 2. It doesn't really make sense to do this for this data. But if you had something like time series, where you want to compare today's value versus 1 week ago, or today's value versus 1 year ago, you can offset it by, say, 7 days, or offset it by 365 days. And you can do a comparison between today and 1 year ago today. Summarize takes a bunch of values and summarize it down to 1, right? You think of the function mean. What does that do? You give the mean function 10 values, and it gives you back 1 value, the mean of those 10. Think of the variance or the standard deviation. Those are summary functions. You give it 100 numbers, and it spits back 1 number. That's what a summary function does. Let me give you your second view quiz answer. Second view quiz answer is E. E as in elephant. E as in elephant. E as an elephant. So summarize is spelled with an S, and that's because Hadley Wickham, the author of the Tidyverse, primary author of the Tidyverse, is from New Zealand, and they spell it with an S. Later on, they added a function summarize with a Z, but I'm accustomed to using the lowercase, the S in summarize. And so that's what I see over here. Okay, that's what I'm going to continue writing. You can use this, that's fine, but I'm gonna keep doing this. Okay, so here I'm going to say I want to calculate values like the mean of the height, variance of the height, mean of the mass, min of the height, max of the mass, and I've created kind of variable names for these things. Count as n, how many values that are getting summarized here. And so it takes all 87 rows, and it just gives me the mean or the average of the things, and the min or the variance and things like that. And you might say, well, isn't it easier just to do mean height in the console rather than creating a summary table? Yes, but by using summarize, I can pair it up with a function called group by, which makes it incredibly powerful. All right, is this okay as far as the summarize function goes? So here's a function, group by, and this is really where I say the power of dplyr derives, okay? we can create groups based on some categorical variable. So here I'm going to take the variable species, a categorical variable. I'm going to create groups based on this categorical variable. So we're going to group all of the humans together, all the droids together, all the people from, whatever planet, we're going to group them together. And when I do this, and then I say select the name, height, mass, species, when I do this, it doesn't look like anything happened. We've got 87 rows still, but it just adds this line, groups. We have 38 groups defined based on species. Okay, whatever. Doesn't look like much has happened. But if I combine group by with summarize, now the summary function applies to groups. So it will split the data into the different groups that it has defined, apply the summary functions, and then bring those back together. So here, my summary function says calculate the mean height, the standard deviation of the height, the mean mass, standard deviation mass, and count them. We've done the group by. So we group by the species first. And now it says, okay, for this species, the Alina species, this is the mean height and the mean mass and the standard deviation of height and the standard deviation of mass. Okay. There was only one character in the data set of this species, so it's not that interesting. But we had six droids, and so the mean height of the 6 droids is this. The standard deviation of the height of the droids is this. The mean mass of the droids is this, and the standard deviation of the mass of the droids is this. So we have applied this summary function to the groups. Okay, and so this resulting table has 38 rows because we found 38 groups in our data, right? Our original data had 87 rows. And if I just said summarize there, it boils all 87 rows down to one row of summary. I take the 87 rows and I said group them by species, and it found 38 different species here. And when I call summary here, now it creates summaries for each of those groups that I've created. And that's really the power of dplyr, group by plus summarize. And it's truly a wonderful thing that I want you to practice using, and you got some practice in your homework 3, which was just posted. So here, we have this problem where each a bunch of species only have one one member of it, so it's not that interesting. So I can take this resulting table, 38 rows, 6 columns, and I can say, you know what, filter it so we have at least something bigger than 1. Okay, so I've taken the same command here that I've written here, and I'm going to take that result and pipe it. So those 38 rows and 6 columns, I'm going to pipe that into a filter where I say I want the count to be at least 1, or count to be greater than 1, count to be greater than 1. And then we're going to arrange the resulting table in descending order by count. Okay, so just like any other science fiction written by humans, humans is the most predominant species. We have 35 characters. Then we have 6 droids, and we've got the mean height of the humans, the mean height of the droids. We have 3 Gungans, the mean height of the Gungans, et cetera, et cetera. Okay, and this is what we have. This looks like a lot, but also I hope you will gain a fluency where you can read through this and understand what's happening. dplyr, when you write them, all of the instructions are done very linearly. Take Star Wars, group by the species, select these columns. After you select the columns, create the summaries, create these new summary variables. Then filter based on the count, then arrange it in descending order of count, and then give me the top 6 rows. You can also use other functions like mutate. All right, so here I'm doing a group by and then a mutate. So the mutate, I'm creating a z-score. Now notice for the calculation of the z-score, we're taking the height variable, subtracting the mean of the height, dividing by the standard deviation of the height, ignoring any missing values. So we're going to do height minus the mean divided by the standard deviation. And because I've run group by, okay, we're going to just look at humans and droids. Because I've done group by species, the mean and the standard deviation is calculated based on species. So notice Luke Skywalker. Luke Skywalker has a height of 172 compared to his species human, he is below average. He has a negative z-score. C3PO has a height that's actually shorter than Luke, 167 centimeters, which is shorter than Luke. Compared to his species, however, his z-score is positive. He's above average compared to other droids, okay? So even though this is 167 is less than 172, 172 has a negative z-score because we're comparing them to the mean of this human species, and 167 gets a positive z-score because we're comparing them to the mean of the droid species. I'm going to take the same code, do the exact same thing, but I've commented out the group by line. I've commented out the group by line. And when I comment out the group by line, now the mean and standard deviation is calculated for everybody in the data. Everybody in the data. And so Luke Skywalker is now above average, so he has a positive z-score. C3PO is below average, so he has a negative z-score. So here, the mean and standard deviation is calculated for everyone, not based on group, or not based on the species group. So you have that. Is that good? Does that make sense to you guys? Okay. We can run group by on multiple levels. So here's just some toy data set. I've got 3 countries, ABC, Afghanistan, Brazil, China. We've got 2 years, 1999, 2000. We've got 2 sexes listed here, female, male, and we've listed off the number of cases, 1, 2, 3. But this is just all kind of made up. This is just a toy data set, just so I can show you what's going to happen. I'm going to create groups based on country and year. Country and year. So we say, how many country year combinations are there? We have 12 rows in the original data. When we group based on country and year, we have 6 groups. Afghanistan 99, Afghanistan 2000, Brazil 99, Brazil 2000, China 99, China 2000. Okay, we're going to group by country and year, and then we're going to create a summary where we're going to just add up the cases, sum the cases. So when we say Afghanistan 99, we have a total of 2 cases. Brazil in 2000, 2 and 2 make 4. Total of 4 cases. So that's what we see. Afghanistan 99, 2, Afghanistan 2002, Brazil 99, 4, Brazil 2004, China 99, 6, so on and so forth. Because I've created groups based on country and year, there is another group, grouping level. We have 6 country year groups, and in this table, there's still 3 groups based on country: Afghanistan, Brazil, and China. So I can call summarize based on this table. So this table says print summary 1. The results of this thing is stored in summary 1. I can summarize this, run summary 1 through summarize, and it will take these values and add the cases, sum the cases for all of Afghanistan, all of Brazil across all the years, all of China across all of the years. So this is fictional. We're just adding up the values across, summarizing it for the entire country, summarizing for the entire country. So we have 3 groups here. And then if I call summarize again, there's no groups anymore. It's just going to take all of these numbers, 4, 8, and 12, and add them together, and we get 24. So that is groups based on country and year. I'm going to do the same thing, but watch what happens. This time I'm going to group by year and then country. So I just swapped the order. Instead of country, year, I've got year, then country. I end up getting the same 6 rows, okay? Except it's just arranged a little bit differently, arranged first by year, 1999, then 2000. But I've got, 2, 4, 6, 2, 4, 6, which is basically what I have over here, 2, 2, 4, 4, 6, 6, just arranged differently, first based on year and then based on country. Notice the internal groups that exist for this summary table, though. Because I've done year, then country, there are internal groups. We're grouping by year here, 1999 and year 2000. And so if I call summary on here, on this table, it's going to group all the 1999s together, and it says 12 cases in 1999. All the 2000s together, and it says 12 cases in 2000. Right? So this is what we have. 1999, 2000, and we have this, and we have this. Right? And that's different from when we grouped by country and year. Okay, same data, just arranged differently. And when we do the kind of multi-level groups, we get different things. Let me go ahead and give you your last view quiz answer. Last view quiz answer is A. A as an apple. A as an apple as the last view quiz answer. Okay, I've run out of time to cover 2 table verbs. You can read through this article on 2 table verbs, but basically this allows you to kind of join one table with another, almost like a lookup table, okay? Join with another table. So here I've got people and states, Adam, Betty, Carl, Doug, and the states CACANYTX. And then let's say this is a lookup table where you can look up the abbreviation CANYWA. CA corresponds to California, and NY corresponds to New York, WA corresponds to Washington. Okay. Intentionally, I have TX not listed here, and I don't have anybody from Washington over here. And the different results are you can do a left join, a right join, an inner join, and a full join, and it will decide which rows to keep and which rows to throw away. The left join keeps everything on the left side table, the people table. It keeps Doug, even though we didn't find a match for Texas, and it doesn't show Washington. The right join keeps everything on the right table, so it keeps Washington, but throws away Doug because we couldn't find a match. The inner join keeps only things where we have a full set, and the full join keeps everybody. All right. Go over these slides in your own time, and also I recommend doing just a little bit of reading on this 2 table verbs set here. Okay, we will end here for today. Thanks for sticking with me, even though I went a couple minutes over. And we will see you guys on Wednesday. So have a good day.